Hi, this is Miss KJ again. How you guys doing? We're here on the 6x5 extension. I just did problem number 1 with you, and you were to try number 2. And now we're going to take a look at number 3. Number 3 is a little bit more rigorous than 1 and 2. And we'll take a look at how we're going to solve an equation with a radical with a quadratic equation involved in solving it at the end. All right, so let's take a look. We've got a square root of 3x plus 7 equal x minus 1. So again, I'm going to start with my good protocol of drawing my line down my equal sign and dividing it into the left and right hand side of my equation. And I'm looking at my equation and I see the left hand side I have the square root of 3x plus 7, and the right hand side I have the x minus 1. My square root has been isolated, so again, to undo that square root, I'm going to square the left side, and because I have to square the left side, I also have to square my right side. Now, looking at the left side, since my square undoes the square root, I'm going to just get the expression 3x plus 7. But now, looking at the right side, I have x minus 1 squared. That's a binomial squared. So what I need to do is, I need to take my x minus 1, and I need to expand that. And I want to do that by foiling. So what I'm going to do first is, I'm going to take the x, I'm going to multiply it by the other x, and I'm going to get an x squared. Then I'm going to take my x and multiply it by my negative 1, and I'm going to get a negative 1x. I'm going to take now the expression, or I'm sorry, the term negative 1 multiplied by x, and I'm going to get a negative x. And then I'm going to take the negative 1 and multiply it by the negative 1, which gives me a positive 1. So now let's look at what we have. We've got 3x plus 7 equals x squared minus x plus 1. Well, now let's see if we can simplify the right side. So we still keep this 3x plus 7, but now simplifying the right side, we'll have x squared minus 2x plus 1. Again, notice that because of the square in this term, we now have the quadratic. And just like we did in our last video, whenever we solve a quadratic equation, we have to get one of our sides equal to 0. So looking at the left-hand side, we want to take the 3x term and the plus 7 term and make this side equal to 0. So what undoes a positive 3x? A minus 3x. Now notice, I'm going to put this minus 3x under my negative 2x because those are like terms. And then my plus 7, I'm going to subtract that. I'm going to put that underneath my 1 because that's also a like term. So now let's look and see what happens. We have our 3x's which cancel, our 7 minus x which cancels, and then that gives us a 0 on our left side. And now on the right side we have an x squared, a negative 2x minus 3x, which gives us a negative 5x, and then a 1 minus a 7, which gives us a negative 6. Now that we have the quadratic equation set equal to 0, again, we want to solve by factoring. So let's see if we can factor our quadratic. We can either do this one of two ways. We can use our box method that we've used before. So let me lift that paper up a little bit. So what we're looking at here is we're looking at an x squared, and again, we're going to set this up with our two binomials. And we know that this is going to be an x in each term because this is x times x. But now, looking at the negative 6, we need two factors. When we multiply, we get a negative 6, and when we add them, we get a negative 5. So that would mean that one of our factors would have to be positive and the other would be negative. So we would have to use a negative 6 and a positive 1 because negative 6 times 1 is negative 6, and this would give us a negative 6x, and this would give us a 1x, and when we add those together we get a negative 5x. So our factors would be x minus 6, x plus 1. Now that we have our factors and we have them equal to 0, we take each factor, so the first factor, x minus 6, set it equal to 0, and add 6 to both sides, and we would get one of our solutions to be x equals 6. And then we take the other factor, x plus 1 equals 0, and solve it, and we subtract 1 from both sides, and the other solution would be x equal negative 1. Again, we have to make sure that these solutions work. So let's go back to the original equation we were given, which is the square root of 3x plus 7 equals x minus 1. So by substituting the 6 in, if we put 3 times 6 plus 7, does that equal 6 minus 1? Well, let's see. The square root, 3 times 6 plus 7 is 18 plus 7, which would be the square root of 25. Square root of 25 equals 5. Is that a correct statement? It sure is. So that means that that would be one of our solutions for sure. And now let's look at when our x equal negative 1. So I'm going to separate this out over here. And now let's go back to the original. And I have a 3x plus 7 again equals x minus 1. And now I'm going to substitute that negative 1 in there. So now this would be 3 times negative 1 plus 7 equals, and what was that, a negative 1? A negative 1 minus 1. Well, let's see. The square root of, that'd be a negative 3 plus 7 would be a 4. Does square root of 4 equal negative 2? That is not a correct statement. So therefore, this solution would be called what is extraneous. So we have an extraneous solution here. We would not include this solution. So therefore, our only solution to our problem would be, let's cross this out, would be x equals what? X equals 6. So now we know that one of our solutions, the one that works, is x equals 6. The other solution, x equal negative 1, is our extraneous, and that would be the correct solution. So this is KJ out. We'll see you again next time.